This lesson is reviewing analyzing factored polynomials. So to start, we're going to talk about increasing and decreasing functions and identifying when they are such. An increasing function, or where a function is increasing, I think of it as where is it going uphill. So up until like that point there, and here where I'm drawing in blue, it is uphill. So it's increasing. I then see I'm now going downhill, so that would be decreasing. A relative maximum is, if you think about the word max, it's like a top value. So in this case, our relative maximum is like a peak in our graph. So that's our relative max. This is our relative min, or minimum. That is a lowest point of that graph. If you notice though, they are indeed peaks, and the reason why they say relative is because here this is continuing upward, here this is going to continue downward. So we really don't know the absolute max or the absolute min. So that's why we use that word relative. Even and odd functions are basically when you're looking at the function at positive and then at the negative of that x value and seeing if they are indeed equal or if they are like opposite of each other. What I think as an easier way to identify them is even functions are symmetrical. So in this case, this column here with both of these examples are even because they are symmetrical around the y-axis in this case. And if we were to substitute in negative x and a positive x into the equation, we would get the same equation after. An odd function is not symmetrical, meaning if we substituted in negative x and x, we would get the opposite function. So here's your odd functions. And then neither is when you do not get the exact opposite. So if you don't get the exact opposite and you don't get the same, it means it's neither, and that's okay. So if we look at this first example here, it says that we're noting the degree is even since we have a degree of 2. An even number. So if you were to graph this, you would see that it looks like a parabola or like a U. But we are going to answer if it displays symmetry, and it does since it is a parabola, so this does. Draw a little sketch. And then it says evaluate f of negative x. So we are going to substitute in negative x. Make sure to put parentheses. Negative x squared is a positive x squared. And notice this function is the same as what we originally started. So this is even since f of x equals f of negative x. The next example here is with a highest exponent that is odd. If we graph this, we see that there is not symmetry. Something like this. And if we evaluate f of negative x, negative x cubed is negative x cubed, so this would turn into a negative 3x cubed. Negative 4 times negative x is a positive 4x. if we look at these two equations, they are opposite of each other because the signs of the terms are all opposite, or one is positive in one, the other is negative in the other. So this is indeed odd, since f of negative x equals negative f of x, or the opposite of f of x.